Okay, well, without further ado, we will get started. So welcome to everybody that's joining us today for this workshop. Really appreciate you taking the time to join us, and I hope you'll get a lot out of this particular workshop session. I'm extremely excited to be here today to talk to you about this area because as I put in my LinkedIn post, I think the issues around certification and governance and biometric frameworks are going to be ongoing, and there's going to be significant tempo increase in 2022. So I think it's a really important topic, and I'm really pleased to be able to share with you today and with some of the other experts that we've got talking on all of the issues around certification and where that is going to be headed in the next few years. We have over 100 people that were registered for this workshop, and I know we've got 29 online now, so very excited to have everybody here for that. I think I'm really keen if people have questions that they would like any of our experts to be able to answer, please put them in the chat. Or you can save them to the end. We have allocated an hour and a half this session, so we will have plenty of time at the end of this for extra questions or for clarifications. As I mentioned earlier, the session is being recorded. You feel free to let us know if you've got a problem with that later on, but yeah, at the moment we will record this session and we'll make it available to all of the participants, especially for those that weren't able to join today. We are very excited also to have a special guest here from MOSIP, Sanjith, who will be talking about their open source initiative in frameworks, and in particular focusing on the aspects related to certifications of devices that will be working with their framework. Before I get into the presentation though, just mention that it's been a really huge year for BixeLab. And some of you who are on the call now have been part of that journey. So thank you all to everybody that has been in touch with or been part of BixeLab's journey over the last 12 months. This year we have become a proper NIST NVLab accredited laboratories. We now have 6 international ISO standards that we are formally able to accredit to. And we also have just finished our FIDO certification as well, giving more information about those sorts of requirements on those certifications during this workshop. We've done over 15 evaluations and provided reports in conformance with those ISO specifications. And we have done what we believe is the world's first voice presentation attack detection assessment as well. So yes, it's been a huge year for us this year, and I think it's going to be an even bigger year next year. Just a quick set of introductions for those of you that haven't met us or that have not had meeting personally. So my name is Dr. Ted Dunstone. I'm the founder of BixeLab and also Biometrics. And I've been involved with biometrics for well over 20 years now. And so I've seen it evolve from a very niche type of operation to now obviously a central plank in all sorts of different areas within the digital ecosystem. With me, just to introduce Stewart Pope, who is a forensics specialist and also very knowledgeable on all things to do with biometric certification. Stewart, do you want to say a quick hello?
Hi everyone, nice to meet you all. Yeah, so as Ted said, I'm an advisor to BixeLab, but in particular with a specialization on laboratories and forensic identification.
Thanks, Stewart. And I'll be handing to Stewart at various points during the presentation for different sections. and Somya Singh, who is our lab manager. Somya?
Hi everyone, very nice to meet you all virtually. My name is Samya and I'm the laboratory manager for BixeLab. I'm in charge of all things to do with biometrics testing and evaluation, whether it's ISO compliance to do with NIST and NV accreditations or FIDO accreditations. Looking forward to the workshop and talking with you guys for the workshop as well. Thanks.
Thanks, Somya. We also have Sanjith. Sanjith, are you on the line at the moment?
Oh, hello everyone. Hi Ted. Hello everyone.
Do you want to give an introduction?
Hey, hi. This is Sanjith here. I take care of the biometric ecosystem initiatives around MOSIP. I'll be speaking about it more in this session. Coming from a national ID background, digital ID background, having worked in programs like India for half a decade, more onto the devices, eIDAS, SDKs, and the biometric ecosystem. Nice to be here, and great to see a lot of familiar faces here.
Thanks, Sanjith. All right. With that, let's get started. So the agenda that we're going to be taking you through today with the workshop is a little bit of an introduction to the work we do at BixeLab. Following that, we have a introduction which just sets some of the scene. Many of you will be quite familiar with obviously biometrics and biometric risk, but it's important to introduce some of those foundational elements. Then Stewart will be introducing issues around eIDVs, that's electronic identity verification, and the components that go into that with respect to standards. I will then be following on to talk about how that relates to national standards and particularly to some of the identity frameworks that are coming up. And we'll focus specifically on Australia's national identity framework and some of the components that go into that from a biometric perspective. We'll then be delighted to be able to have Sanjith talk about the MOSIP platform and particularly the standards and authentication requirements around MOSIP. And we'll also refer to the issues in some of the other national identity frameworks that are being developed at the moment as well. And finally, some more specifics about the services provided by BixeLab that relate to these particular types of certification. So a very quick introduction to BixeLab. BixeLab has been involved in a huge range of different types of evaluations from lots of different face vendors, but also lots of fingerprint, iris, and voice in application domains that span everything from government through to financial service providers and even industries such as mining, for instance. So, there are a huge range of different use cases. BixeLab was only founded at the beginning of this year. And so some of these clients are clients which have been involved with Biometrics in the past because Biometrics has done this work, testing and assurance work, as we mentioned, for many, many years. But we're very excited by the width and diversity of different types of applications that are using biometrics and the sorts of the demand, if you like, for understanding more about how biometric systems are operating to manage risk. So most of you on the call obviously would know what biometrics are, but they basically are looking at the physiological, physical, or the behavioural characteristics and identifying unique traits which can help to distinguish one individual from another. There's a huge span of different types of attributes that can be used, and indeed the set of different types of biometrics for a range of different purposes is always expanding. I recently saw there was some patents around the use of pulse in for people that were wearing sort of wireless headsets. So we think about the main biometric modalities being face, fingerprint, iris, and voice. But there are a range of different technologies that are appropriate in different types of applications. But they all share very similar metrics when it comes to how you go about doing the evaluation and the sorts of things that you're looking for to make sure that they are going to be accurate and not vulnerable. So let's start the presentation around talking about biometric risks. So biometrics are commonly used to help control fraud within an environment. And so one of the key factors associated with controlling that fraud is understanding what risk factors. Risks come in a whole variety of different forms, and not all of those risks are specific to the biometric. There are obviously many risks that relate to issues to do with IT security or human factors or the way that things have been set up or privacy. But there are a whole range of things that, for instance, where you get codependencies. And I'll give you an example. So for user interface, if a user interface isn't well designed, then it's possible that when you are capturing the biometric, you won't actually capture a very good biometric, or the biometric will have issues. I'll give you an example of this, an application that is capturing a selfie where the information that somebody needs to read whilst they're using the selfie is not aligned with the camera, so that every time that the photo is being taken, the photos that are transmitted are all of the person not looking at the camera. So you're basically not getting a front-on view. So this is a case where it's not a problem with the algorithm, it's a problem with the user interface, the way the user interface itself is designed. And that's just one example of the kind of codependence that you can get with these sorts of systems. So when you're doing an evaluation or when you are looking at risks, those risks really need to feed into or be part of an overall risk management process, and identifying what sorts of things might happen, how likely is it to happen, what the impact will be if that particular risk happens, and then what sorts of things can be done to reduce the exposure to that risk. And from a biometric perspective, there are a number of pieces of the puzzle that feed into that risk. And they are the accuracy of the system. So how accurate it is, for instance, at saying that I am Ted, as opposed to misclassifying me as Stewart, for instance. Vulnerability. Is it possible for me, if I was showing a picture of Stewart rather than my live face, for that picture to be recognized? And quality. If I can take if I can use an enrollment photo that is not of good quality, then it's going to be a lot more vulnerable if I'm able to also present an image which is also of not good quality. So quality is essential. Quality and quality management is essential to any biometric system operating effectively. To illustrate this point, we basically have what we call the biometrics performance triangle. And that triangle has accuracy at the top. And accuracy, as I mentioned, is the sorts of things that you often think about from a biometric system, which is the chance of a false accept and the chance of a false reject. There are a number of other metrics depending on what you're trying to measure, but in essence, it's how likely will the system will reject you or accept an imposter. Accuracy itself is not a static point, because we all are aware of the issues to do with bias in biometric systems, and those issues are also issues that relate to accuracy. In addition, accuracy that is to do with me compared to Stewart would be different from accuracy when me compared to my brother, because we share genetic relations. Then there's more similarity, so we're more likely to have a stronger score. Vulnerability is a whole area into itself, and this is what's commonly known in the biometric world as presentation attack detection, and colloquially known as liveness. And that is, how can we tell that the biometric is being acquired from a real person, not from some artifact? We'll unpack some of the nuances of that in future slides. But I wanted to tie that idea back to the risk issues that we talked about earlier, because in essence, when we are identifying vulnerabilities, a vulnerability to a system is not just a pass-fail. Vulnerabilities are things where you can have a probability or a likelihood, and no system, no matter how secure, is perfectly resistant to all types of attack. And so it's quite important to understand what sorts of attack might be relevant for your particular system and what sorts of things can be put in place to help mitigate that risk. And the final leg on that, the triangle, is quality. And I cannot emphasize how important quality management is, because the old saying goes, garbage in, garbage out. And really, if you don't take care to make sure that your system is designed to monitor, to measure, and to correct quality, you can end up with a whole lot of data within your system that is just not able to be used to effectively bind identity. And we've actually seen a number of large projects where that has turned out to be the case, and a lot of money has had to be invested to help correct that particular issue. So for here, I will turn over to Stewart.
Thanks, Ted. So we're going to move on to talk about biometric testing as a general concept before we move into what the real difference is between this type of testing and something that is the accredited type of testing that we perform as per the NIST and FIDO and related standards. One of the big challenges in biometric system testing is that what you are actually testing varies a lot. In some cases, it may be simply a piece of software, like a matching algorithm, like we are sent something like that, maybe by email, USB drive, or whatever it happens to be. In other cases, we might get tested, it may be a mobile app on a device that's sent to us, or a mobile app that we install on our lab devices. There's also things like access control units, which they contain everything in one, right? They have the sensor as well as the matcher and any presentation attack detection, and it's all within the one unit. So one of the challenges in biometric testing is how can you test all of these different types of things in a way that is effective, useful, and standardized, and provides some point of comparison. And between these different devices, it may not be possible to do that by automated technology evaluation. It may need to be done by a scenario, by actual physical testing, by a test crew. And that is one of the key challenges in approaching, applying good rigor to biometric testing. So biometric systems they're inherently probabilistic, and that means that when we do testing, there's a lot of different factors that we need to consider, and things like the scale of testing as well, and environmental conditions that introduce that variety. And now that we have biometric systems that are based on machine learning and artificial intelligence type technologies, this also adds an additional element. So what we provide is independent third-party testing through our laboratory, and that plays a crucial role in enabling customers to navigate the biometrics market smoothly. And this type of standardized testing is kind of becoming increasingly important for things like digital identity programs, as well as just being the gold standard, I suppose, in providing a solution that gives a potential client confidence that the system is working as it should. So now that this testing is becoming increasingly formalized, there's a lot of different standards and frameworks that can be applied over the top of this. There's ISO 19795, which has been around a while, and that really relates to the accuracy component and how we do testing for accuracy and reporting. However, it really doesn't include anything about, like Ted was talking before, about vulnerability and presentation attack detection. That's covered by the 3107 standard, which is a bit newer. And has other parts of it which are much more recent as well, particularly around testing of mobile devices. There's a new part there. Then there's the FIDO biometric requirements, which specifies a bit of a type of test or a way to test both accuracy and presentation attack detection in order to achieve accreditation against that. But over time, there's also been a lot of other different frameworks and things that have popped up. So there's the BEAT framework out of the European Union. NIST have also put together the SOFA-B framework. It's a bit old now. And there's also other commercialized or proprietary frameworks of ISO 17025 laboratories. But within that, there can also be other different types of standards which might become relevant. Things like standards around quality, around the role of human examiners, and new ones that are yet to be developed or are still in development. So depending on the type of system, different types of standards or frameworks may become relevant. But over time, a lot of those frameworks like the BEAT framework and the SOFA-B framework have really, a lot of that work has been pushed into the ISO standards up the top of that list over time. So really the next evolution of those around that is talking around eIDV solutions and around digital identity. So an eIDV or electronic identity verification solution, these types of products have been around a while now, and they're in common use, particularly in the banking sector. And it's the type of product where you use your mobile phone as a customer, you take a photo of your driver's license, passport, or other document, and then you take a selfie, and then you do a match between those two, and then usually also applying some level of automated document examination over the top of that. This type of technology is really only possible now because things like biometrics have come a long way and are much more accurate than they used to. This type of use case, would not have worked, I suppose, a number of years ago, but it is possible now. A large number of different technologies to create a complete end-to-end solution, particularly things like, as I said, the financial sector for onboarding. And they range from solutions that are fully automated through to solutions that are fully manual and ones that are in between. So what I mean by that is automated solutions using solely biometrics and automated technology versus manual solutions where that technology is largely used to automate parts of the process, but ultimately the decision is made by a human examiner. As I said, these technologies have been around a while now, used in lots of different use cases, and this sort of predates the much wider and larger scale things that we see now in digital identity frameworks. But the technology that used in these types of products is very similar. As you can imagine, by roping together lots of different pieces of technology in that process, there can be a lot of different types of risks exposed because you're talking about a mobile app, you're talking about elements of a document, and you're talking about elements of a face. So there's lots of different potential vulnerabilities that could be exposed to that, and they do relate to things like Ted mentioned before around usual accuracy problems, presentation attacks, and quality problems. But you also introduce other elements like particularly around the document, where that document might be copied or fake, and also opportunities where someone might be able to substitute the biometric data in that, essentially putting in a different photograph. So lots of different potential things. I won't go into too much detail about that, but this type of eIDV product is really underpins at the front end of these digital identity frameworks. A lot of them rely on largely this sort of process with other elements over the top as well. One of the things that really differentiates a using digital identity is often those really rigorous sort of third-party checks that might not be present just in an eIDV product on its own. and the kind of directions that this going. So where using digital identity and things like that was particularly popular in for government in Australia, things like accessing MyGov would be one that be familiar with. Also seeing wide use in the financial sector for customer onboarding and those types of identity checks. But it's becoming a lot more accessible for other types of use cases as well now. So we're seeing these types of eIDV and sort of digital identity type products being used for other things like travel around visas. COVID passports would be obviously a relevant new one as well. Telecommunications sectors, social platforms, that's an interesting one. So Facebook obviously doing a lot of different biometrics and reducing fake accounts and those sorts of things. And yeah, a wide range of different use cases. And that's really what happens with a lot of different biometric technologies. They start at a level where they're used for very, very large scale government type projects. And as that technology improves and becomes more accessible, it filters down to the other sort of smaller use cases as well. And digital identity is no exception to that. And with that, I will hand back over to my colleagues to continue. Thank you.
Thanks, Stewart. Yes, this is a good lead in to essentially the current state of digital identity frameworks, standards and systems, because I do believe that with the current momentum in the world around biometrics and privacy, there's obviously many people will be aware, a lot of concern in a lot of places about how biometric technology is being used. Much of that concern is maybe not warranted, but beside the point, there certainly are systems that have been applied to inappropriate sorts of use cases, or have not had all of the controls or checks that need to be there. So I think it's inevitable, as with probably any technology, as it becomes more and more widely deployed, that it will there will be governance processes that are put in place. There will be legal constraints that will be put around what sorts of technologies can be used for what sorts of applications and what types of testing are required. When I go and buy any electrical piece of equipment, I can trust that I can plug that into my wall socket and not burn my house down, because I know that it is past government mandated levels of certification and testing. And I think that is where we are headed with the application of a lot of biometric technologies. We're just at the very start of that process internationally. Some of the things we're talking about today are the precursors to more general things that will be happening globally. But it's certainly to be hoped that we don't end up in a world where we essentially have a different wall socket plug for every different country. So the idea will be to try and make sure that we have national identity frameworks that have some alignment no matter what country you're in, so that if I'm certifying a product in Australia, I will know that that product will also meet Singapore's certification standards. Now, we're still some way from that point, but I certainly, I think within sort of the 5-year time horizon, we will have multilateral recognition of some sort around these sorts of identity frameworks, and that will actually unlock an awful lot of value beyond just identifying for government and for financial purposes. For instance, in the legal area and in the area to do with conveyancing and property, there's huge issues and huge opportunities to do better as long as we can make sure that the identity infrastructure is secure and is trusted. And it's going to be not just trusted internally, but is trusted by all the people, all the consumers out there that need to use it. And so we've broken things down in this slide to 3 different types of area. we have what we call the national accreditation frameworks. So these are the frameworks at the government end, which are designed to try and be like a gateway, like, as I mentioned, like a check to make sure that if you want to use your system as part of a government related identity, that it meets the minimum standards. So that's what TDIF is, and I'll talk about that in a little while. But Singapore has their national digital identity, of which SingPass is a critical component. In Europe, they have the Electronic Identification and Authentication and Trust Services legislation. The UK has legislation which is being built at the moment as well. So there's many countries are looking to build or flesh out these digital identity frameworks. The second box here relates to specifications and standards, and they're the common sorts of things that we traditionally have talked about in this area, which are the ISO, International Standards Organization standards, and there are a variety of those related to checking biometrics. The most commonly known ones are the ones around presentation tag detection, because that is commonly what is required these days for many tenders. But the ISO ones, which relate often accredited through the NIST, which is the US National Institute of Standards and Technology, that they're one set of standards, but there's also standards around FIDO, which is another sort of identity provider where the identity is specifically bound to some kind of mobile device. Android also has a specific program around making sure that handsets, mobile handsets, reach some forms of minimum standards for the built-in biometrics. Suffice to say, though, that many of these specifications and standards are, despite some of them being quite old, are really still very much evolving, and I think there will be a continual evolution of what's required in those standards. There is continuing evolution of what's required in those specifications and standards. And finally, we have the systems which underpin these, and so there are a range of different types of systems. So mentioned before, we're delighted today to have the MOSIP platform being introduced, which is open source version, which allows biometric components to be plugged into it, and actually has achieved an impressive amount of adoption by a range of countries in a short period of time. But obviously, for these digital identity systems, there are also a wide variety of vendor supplied systems as well. So we've talked about the digital identity frameworks, and a key aspect of those digital identity frameworks is making sure that the technology components that are included can be trusted to deliver on their promises associated with accuracy and detecting imposters. And so when you are building a trusted digital identity, sorts of things that you're keen to make sure are that obviously you have here the biometric performance has been tested, that you have some way of making sure that in an ongoing fashion the system is continuing to meet those standards, because a test is a point in time, and certainly things change, or even to make sure that settings and things have been set up correctly when things go into production. There's the manual side of biometrics. Certainly for large-scale national digital identity, there's often a case where it's necessary to have some manual components, whether that's manually verifying for local transactions where people don't have documents, or where that is manually verifying the output or manually checking the output of uncertain cases where you have a technology decision. There are all sorts of issues to make sure that the people's privacy has been respected because of the sensitivity of the data. And then there are issues related to data security and making sure that the biometric data or any personal identifying information isn't compromised or misused. And a key plank of that is making sure that you've got a qualified third party that is able to do that kind of assessment. If we're looking at what sorts of assessment relate to biometrics, we have these three different areas, which again go back to our biometric triangle. You have quality, where you have a sensor. Is it acquiring the quality that is required to meet accuracy requirements? That might mean for a fingerprint system that you are collecting with the right precision, but it might not just be about DPI or dots per inch. It may have a whole range of different things which relate to how sharp an image is, how much feedback is given to a user in order to get a good capture. So there's lots of things that go into checking quality and making sure that you've got a good quality filter so that the biometrics that are required are going to be useful for binding identity. Then there's accuracy. So once you have the data acquired, how well does the technology do at distinguishing, not just between myself and another person, but between myself and a demographically similar person. So in my case, my age from roughly my background. So question is, first of all, what level of false rejections are we getting? What level of false acceptances? But also, are there potentially biases or are there issues with subpopulations? And finally, there's security, which is in a biometric context. If we look at people that might like to attack the system, how robust is that system going to be against those particular attacks? This is quite complex to determine because there are obviously a wide range of different types of artifacts that might be used. And it's why it's so important to get a qualified independent testing laboratory to assist with that process, because otherwise it's very hard to have a standardized way of measuring that unless you have a lot of experience and the right tools and techniques to undertake that testing process. There are also different ways that a system can be tested. There's the system testing from end to end, so where we're looking at the whole of system process of checking the solution with all of its components. So its liveness, its technology, any document reading as one, because as I mentioned before, there are all sorts of different ways that the different elements of a biometric solution can affect each other. If you don't have good quality controls, then that's going to affect your accuracy. And it can also affect vulnerability. If you don't have good accuracy management, or if you don't have good vulnerability management, then that is going to have an impact on your accuracy as well. From an identity framework perspective, it's not enough to merely say that the point components within a solution have been tested. It's really important that the end solution is also evaluated. It's the rough equivalent of testing safety in a car. If you've tested safety in a car and all you've done is check that the wheels operate safely, well, that tells you something about the safety of the car, but it certainly doesn't tell you everything. From an assessment perspective, national ID, you frequently require some way of making sure that the people that need to be able to do some form of manual comparison, so non-electronic comparison, are able to do that in a controlled way, particularly in a facial comparison section. And so you need to be able to train them, and you need to be able to test that they can do that process. there's a fair amount of development work which is happening right now in that area. Over the next 12 months, I expect that will significantly mature. Then there are assessments around privacy to make sure that the issues to do with make sure that any data which is flowing through the system is handled appropriately, is not sent to the wrong places, and is removed once it isn't required anymore. In particular, I will just take as one point example the TDIF, which is the Australian Digital Identity Framework. We've been involved with some of the work in that particular area, but it's basically been a framework developed by the Australian Digital Transformation Agency, and it's designed to replace and supplement all aspects with the proof of identity process in Australia. And to that end, it lays out all the requirements that the applicants need to meet to achieve that sort of accreditation. In other words, to be able to make sure that they meet a minimum standard before they can offer digital identity services. There are a range of different guidance materials and templates which are helpful in supporting that. And whilst we're talking at the moment, obviously, about the biometric components, any digital identity framework is bigger than just the biometric components and includes a whole range of other aspects that need to be, that solution providers need to be compliant with as well. There's essentially, from a TDIF perspective, the provision of a identity information, and then the binding of that identity information. And the binding of that identity information can occur in a range of different ways, through either passports or via an exchange process which allows connection to to various identity providers. And in the TDIF specific biometric requirements are couched around making sure that online biometric binding can be achieved. This is where the biometric binding takes place against the source. Essentially, we have a system called a facial verification service, which connects to a range of different back-end government systems, so that it can check in a one-to-one fashion against your passport image, or potentially an immigration image, or a variety of other sources. And so that provides a very secure mechanism for binding of biometrics, because it's checking it. It's not trusting a third party. It's able to check directly with information that is already held by the government. There's the issues, as I mentioned, around making sure that the logging and data retention are correct. There are issues around making sure that the image quality detection meets a minimum set of standards. There are standards around making sure that the presentation attack detection meets the required 13107 requirements, but because of the current ISO standards in that area are not very prescriptive, it's often necessary to supplement the standard by being a little bit more specific about what sorts of artifacts and what number of artifacts are being required. It's certainly the case that not all testing certificates will test to the same level of rigor at the current point in time. And then there's risk. And so this is about how a solution is being managed from a risk perspective. And that involves making sure that the solution providers are able to demonstrate that they have thought about what risks exist to the solution, and then what sorts of things are being done to manage those particular risks. Essentially, this slide really just summarizes the fact that there's the accreditation process and that there are a variety of different authentication mechanisms that are authorized at the current point in time. They are the source, as I mentioned, where that goes back to the source biometrics that are held by a identity provider. Technical, where you could connect to a passport or potentially an electronic driver's license. Local, where you have a human as part of that loop. And then we're under assessment, we also have what we call solution implemented biometric binding, which relates to where we are actually taking a photograph of a document and using the image from that. Now, obviously, that comes with a huge number of other risks because then you are subject to a range of different types of document fraud. And so, you know, it needs to be used with a great deal of caution and with a great number of controls around it. The accuracy requirements in this area are that basically specified for TDIF around a 90% confidence interval. And tied essentially to, not tied to, but inspired by, if you like, the requirements that are encoded in the FIDO specifications. And these translate to a minimum of 245 test subjects in most cases for this sort of one-to-one verification scenario. It's one of the reasons why it is complex and somewhat expensive to run a full-scale test, because the requirements on getting test subjects and managing that test process obviously does require a fair amount of time and energy from the laboratory. I think this is the point where I'll hand over to Somya to present this section. Thanks, Somya.
Thanks, Ted. So I'll start with NIST. NIST stands for the National Institute of Standards and Technology. And NIST, when we talk about biometrics, has had a monumental impact in the field of biometrics. With the help of their standardization practices, they've ensured essentially that the biometric systems across the globe are both accurate as well as interoperable. Among some of their activities to do with biometrics are research activities on all sorts of biometric modalities, which include fingerprint, face, iris, voice, DNA, as well as multimodal biometrics as well. They have also been developing international standards, best practices, as well as specifications. And we all know about FRVT testing, so technological testing and evaluation, which essentially leads to innovation. As an example, I want to talk about the special publication 876-2, which is to do with the personal identity verification. It is used across the globe in conjunction with specifications such as Federal Information Processing Standards, FIPS, for a whole range of identity management systems across. In terms of modalities, this specification covers fingerprint, iris, face, and it's also got some references to biometric sensor interface. It refers to what's known as Biometric Identity Assurance Services, or BIAS, where BIAS essentially standardizes remotely invoked biometric services by defining frameworks for deploying and invoking biometric-based identity assurance capabilities that can be readily accessed using service-based frameworks. The standard is also interesting. The specification is also interesting because it establishes some minimum accuracy specifications around biometric authentication processes. For instance, it's got minimum allowed false match rate of 0.001 for face and finger, as well as 0.0001 for iris. So that's something that's quite interesting and can be utilized in a lot of scenarios by a lot of organizations as well. Moving on to NVLab. So NVLab stands for National Voluntary Laboratory Accreditation Program. It's a program that has been established by NIST. And what it does is it accredits third-party organizations to be able to perform standardized and formalized biometric testing. BixeLab is an accredited lab accredited to perform biometric testing by NVLab, and we've got 6 international standards under our accreditation scope, which range from biometric performance testing and reporting through to presentation attack detection testing as well as reporting. When we talk about the evaluation of biometric performance, this can be just based on the specifications of 19795 series, especially -1 as well as 2. This can be done using 3 main types of evaluations, which include scenario, technology, as well as operational. When we talk about scenario evaluation, this is essentially an end-to-end evaluation of any biometric system, and it can be conducted with the help of live conformant test subjects. So we have to reach out to volunteering test subjects to be able to conduct this type of evaluation. And this evaluation type translates to reporting of the system performance in terms of error rates such as false accept rate, false reject rate, failures to enroll, acquire, etc. Just based on the confidence levels that we derive using the specifications of 19795-1 as well. Moving on to technology evaluation. This is the measure of the biometric matching accuracy of any algorithm. And this type of evaluation is conducted with the help of a suitable test corpus or data set that is representative of the target population as well. This type of evaluation translates to reporting the biometric matching performance of the algorithm in terms of error rates such as false match rate, non-match rate, with essentially higher confidence levels in comparison to what can be achieved through scenario evaluation types, just owing to the practicability of this evaluation as well, because you can use a data set, whereas you need a test crew for scenario evaluation, and confidence level can be derived based on the test size. Moving on to operational evaluations. Operational evaluations can be conducted according to the specifications of 19795-6, and they can be essentially conducted to identify the real world deployed performance of a biometric system, in most cases to verify the production, that the production performance is reflective of the performance that the sponsor of the solution expects. Then we talk about ISO 30107 compliant evaluations. What you can see on your screen here is just some instances of the types of presentation attack species that we utilize when we do conduct our ISO 30107 compliant testing. So in accordance with the specifications of 30107, what the subject matter experts over at BixeLab do when they're designing the test cases for any client is that they base the test cases off of what's known as attack potential. Now, according to 3107, again, attack potential is the measure of the capability to attack a target of evaluation, given the attacker's knowledge, their skills, the resources that are available to the attacker, and their motivation to conduct the attack as well. So there's quite a few parameters that go into the categorization of the types of attacks that are utilized in either level 1, level 2, or level 3 type of PAD evaluation. Then moving on to FIDO. FIDO stands for Fast Identity Online. Now consumers throughout the world globally, they're rapidly adopting biometric authentication. That's partly owing to the fact that hardware manufacturers are enabling its use, but it's also mainly owing to the fact that FIDO Alliance has a set of authentication standards, which is increasing the ease with which the authenticators are able to use the mobile devices over web interfaces, and with increased usability, that is decreased friction for the consumers as well. FIDO Alliance has a set of specifications. I'll discuss some of the specifications. For instance, UAF. So UAF stands for Universal Authentication Framework. What it does is it allows the relying parties to leverage the diverse set of security capabilities that are available on any end user's device through a single unified protocol. There's also U2F, which stands for Universal Second Factor Authenticator specifications. These are open specifications that set criteria for two-factor authentication with the help of USB or NFC type devices. Technologies, similar to the sorts of security technologies that are found in smart gates. The current certification efforts include functional certification, certified authenticator levels, and biometric component certification programs. BixeLab has been accredited by FIDO Alliance under the Biometric Component Certification Program to be able to conduct FIDO compliant testing. When we talk about FIDO compliant testing, what are the key requirements set out by the FIDO biometric standards? So when we talk about biometric performance levels, there's two key requirements. There's a target false reject rate of 5%, which the target of evaluation, that is the system that undertakes the testing, needs to achieve with a confidence level of 80%. And there's also a false accept rate requirement, which is it must be less than 0.001%, and this accuracy needs to be calculated with an 80% confidence level. When we talk about presentation attack detection, FIDO also has specifications and set targets around PAD. So it requires the use of both level A as well as level B type presentation attack species, and it has set out the requirement to be an imposter attack presentation match rate to be less than 7% for both levels A as well as B presentation attack species. So there's a quick snapshot on FIDO as well as NIST. I'll quickly hand over to our guest speaker, Mr. Sanjith, to introduce us to Mohsib.
Hello, thank you, Somya. Yeah, so once again, good morning and good evening, everyone. And the next 10 minutes, I'll give a very quick overview of MOSIP. Yeah, so MOSIP is an open source project hosted at IIITB, a leading university in India. And we are a not-for-profit initiative and funded by philanthropic agencies BNGF, NORAD, Tata Trust, and Omdia Networks. So the primary responsibility of a foundational ID system is to issue verified and unique identities and offer multiple channels for performing identity verification. MOSIP is a very powerful and robust platform using which the foundational ID systems can be built. So primarily for ID issuance, identity verification, and ID lifecycle management. So the question is, what makes us different? So there are a couple of points to highlight here. The first one is the APIs and standards that we use are open. They are largely adopted. So we could hear from Ted and Somya a lot of standards. So we are primarily following ISO 19794 for the biometric images. And for the data exchange, we are following CBUF to give an example. So this will enable seamless communication between various modules and the integration points. The second is we are fully open source, so available to anyone under Mozilla Public License 2.0. We follow a modular platform approach. So usually if it's a national ID program, generally the ID program will be monolithic in nature. So we are unbundling that into multiple modules that talk to each other. And the final ID system, for the final ID system, these modules become the essential building blocks. And the residents, that data privacy and security, these are the highest priority for MOSIP platform. By design, we are effectively preventing vendor lock-ins and also achieve interoperability with various other systems. So since MOSIP is a platform, building a fully fledged foundational ID system will need additional players and solutions. So the ecosystem is displayed here. So we are not an end-to-end plug-and-play solution. It's a platform, and it's a foundational identity platform, and we need a system integrator to develop, integrate, deploy, or maintain as per the user or country's requirement. And similarly, we don't have any inbuilt capabilities to process biometrics. So say biometric acquisition, the deduplication, or say even print a PVC card, the credential. So for all these purposes, the commercial ecosystem components come together and they form the integral building blocks of the final foundational identity system. And needless to say, the success of the final ID system is also dependent on how good these external components are. So we have defined standardized interfaces and service definitions for all these external components. So we have started our project back in 2018. So we have completed about 3 years now. So got open sourced in July 2019. And currently we are working on a long-term support release. With a lot of features, functionalities, and then focusing a lot more on the reliability aspects of the platform. So as of now, we have about 6 countries adopting MOSIP in various stages. So countries like Philippines, Morocco, and Togo, they are focusing on full rollouts, while Sri Lanka, Ethiopia, and Guinea, they are focusing on pilots and POCs. And going forward, you will see an exponential growth in the list of adopters in the coming years. Seeing the real value of a open source platform like MOSIP. So I'll spend some time on this slide because I think this is more relevant to our discussion here. So before any biometric product or a device gets deployed in the ID system, the countries will need minimum assurance about the product itself. And the primary question is, who gives that assurance? So the assurance is needed on 4 aspects. So the first one is on the interface itself. How are you connecting to the devices? What are the functionalities offered by the devices? So MOSIP, we have developed a standard for biometric devices. We call it as Secure Biometric Interface, SBI. And SBI primarily focuses on following problem statements. The first one is interface must be standardized. So that means you need to seamlessly switch between devices. The country should be able to just switch between devices without changing a single piece of code. Second, the different technologies, platforms, and communication interfaces must have a standard way of communicating with each other and with the ID system itself. There has to be mechanisms to prevent scalable attacks like a biometric replay or biometric injection to the system, and devices must be cryptographically traceable to validate that only qualified devices are connected to the platform. And the last point on the interface is the capture itself must be purpose driven and must support Web 2.0 protocols. So our SBI, the Secure Biometric Interface, was developed on these principles in mind. Now again the question it comes, who will assure that SBI was developed properly? Now the second aspect is with respect to second aspect where an assurance is needed is the image quality. And the first point is the good quality, a very good quality biometric acquisition is needed for the accuracy expectations of the ID system. And the quality, it must be maintained over the lifetime of the biometric device, which is typically we treat it as 5 to maybe 3 to 5 years. And it must be protected against any compromises in quality due to wear and tear, very important aspect in a national ID. The last point there on quality is the ultimate focus must be on inclusion. So that means for the incapability of a device to obtain a good quality image, the residents must not be excluded. That's a very critical point on national ID programs. So third aspect for assurance is the device hardware. So just like we know in payment industry, we have devices certified as PCI PTS for using in financial transactions. We have requirements for hardware-based security models, effectively handling some of the biometric, some of the threats like biometric injection and a couple of other threats. So hardware is also a major component where the certification aspects must cover. When it comes to technologies, again, we have contactless technologies. They are gaining momentum. While the technology is maturing, the capture could be done with a normal off-the-shelf mobile camera or a purpose-built hardware. And there are other operational aspects coming to temperature, humidity, IP ratings. This all will vary for different countries and conditions. And another important aspect is health and safety requirement. That's also very important. For example, an iris scanner with a very powerful IR LED that could be harmful to the eyes. And you also need to define what is acceptable for specific age groups, especially children. And now, the fourth one, we strongly recommend the industry adopting the best practices and continuously innovating so that we always evolve to something better. So that means there could be a forward-looking country-specific requirement on top of the basic requirements that are discussed here. So for instance, presentation attack detection, Ted was speaking about it. So this is a serious issue. There are standards available, there are certification schemes available, and there is a good momentum on the number of products undergoing PAT certification. Now, when we talk about the certification schemes, there are some practical challenges to be discussed. The first one is with respect to the technologies. So MOSIP as such, so we are agnostic to the capture technologies as long as a good quality biometric image is given out and the security aspects are maintained, we are covered. But then when you look at a fingerprint device, for example, the technologies, there could be multiple technologies, optical, capacitive, multispectral, active thermal, LES, many of them. And the assessment models might be different for each of them. So the point here is a good and new technology, it must not suffer just because there are no evaluation schemes. So that coverage with respect to technologies is very important. And coverage with respect to modalities, that's also important. For example, for various use cases, the preferred biometric modality could also vary. Identity verification using a feature phone. So maybe a voice biometric could be the most powerful mechanism because it does not need any purpose-built hardware. Now, one important aspect is when a testing is done on specific sample datasets or over a lab, it will provide a good indication on the device capability, very good indication on the device capability, but the results could slightly vary when you take the device to the field. So the point to note here is that the certification scheme, sometimes it need to be complemented with a statistically significant samples from the target geography to arrive at the final conclusions. So it could be a small FAR, FRR, testing done by the country themselves. And finally, the interoperability of the device with the ID system, that's very important. The definition of quality is sometimes relative. So right now we are working on a problem statement where we are trying to figure out there are 3 players, all of them saying, hey, we are good, device is good, ABS is good, SDK is good. So trying to figure out who is really good and who is actually at fault, right? So when we look at the quality aspects of an ID system, we should look at that in a very comprehensive way, not as a disconnected component such as the capture device alone. Now, some more points. With that, I'll wind up my presentation. So MOSIP is currently working on establishing something called experience centers across the globe. So where anyone can come get an immersive experience of MOSIP by walking in, pick and choose devices, solutions, and undergo full registration and walk out with an ID. So integration of devices to MEC and validations against the test utilities developed by MOSIP. So that will offer an advanced level of assurance on the functionality or interface compliance of the device. But then all the other requirements listed, including the biometric quality, that will need specific laboratory setups for an evaluation. And going back to the problem statement highlighted above, many countries do not have a certification infrastructure or a lab setup. So the question is, what can be done here? So what we did is we started our work to create a certification framework for labs to adopt with an objective of creating an ecosystem of empaneled labs in various geographies. So countries can choose to approve certification from one of these labs as criteria for a device to operate in their ID system. And this is also a positive move for the device manufacturers as they may not need to undergo complex certification in each and every country. Instead, certification from one of the empaneled lab might help positioning the devices in multiple countries. So this is still in very early stages, and the coming months you will hear more on this from MOSIP. So I'll wind up my session with an important thought. Certification scheme, it must be very practical. It should be clearly drafted, comprehensive, achievable, cost-effective, fast, and most importantly, it must be designed in consultation with the biometric device ecosystem itself. And if you want me to pick one word that we must really focus for, that is inclusion. So once again, thank you so much, BixeLab, for inviting me, and thanks everyone for listening to me. Thank you all. Have a good day.
Thank you for that very much. We'll move on. Thank you. We are accredited to provide all types of testing for all the different types of frameworks that we've discussed throughout this this workshop. Accredited to provide all those different types of testing. However, that's not necessarily the aim of all different types. So we have a few other offerings that we've provided that may be of interest that we'll talk about here. A red teaming type evaluation, it's a combination of all of those different elements of accuracy, quality, and vulnerability to expose different types of potential vulnerabilities within a system that you might not uncover just through a simple presentation attack detection evaluation. So a typical one here might be in a presentation attack detection scenario, you might test a photograph or something simple like that, whereas a red teaming type evaluation would look at, well, what are the features of that use of a photograph instrument that might produce a different type of result. Maybe it's the lighting, maybe it's the way it's held, or other different characteristics rather than just the artifact itself. So also the next one is a level B, bias type evaluation. This is becoming increasingly relevant, and when you hear the term bias, a lot of the time people will think about talking about biometric matching accuracy and that type of bias, which has been a topic for several years now. But one of the other upcoming areas of interest is bias, not necessarily in the accuracy part, but in that presentation attack detection technology. We're looking at different types of evaluations and addressing and managing and evaluating and measuring levels of bias, whether it is for accuracy, but also for that presentation attack detection scenario. And then lastly, we have a subscription model type analysis. So as with lots of other things, this type of testing that we do usually comes with a period of 2 years for a standard sort of level 1 or level 2 PAT evaluation. And we can provide those types of evaluations over the life cycle of a product with a substantial discount and through that continuing process. And it extends beyond simple testing. We also have different types of analysis services. So it may not just be testing, it may just simply be analysis of a data set that you're interested in, like what is the quality that exists within a data set. And that's a good type of evaluation. So you can gain an understanding just of the quality that exists within your system, for example. We can have through our partners as well with cyber and data services. So checking cybersecurity at the same time that you're looking at elements of biometric performance and vulnerability can be really important. There's different types of attack vectors that you can test that combine different elements of cyber and of biometric performance testing. Auditing and reporting. So some of our clients, we provide both tools or otherwise ongoing assurance reporting against the system. And that's really important to look at the performance of a system over time, as that can be useful when you go to make different decisions around are you going to upgrade, are you going to change configurations, and when you have that historical data, you have a good basis upon which to make those decisions. And then lastly, we also have training services, so we can provide in-person and remotely delivered training on all different types of topics within biometrics and identity. One of the key ones I'll note here relevant to the digital identity programs is we spoke about the Trusted Digital Identity Framework in Australia. There are specific requirements in there around operators receiving some level of training in a lot of different areas around fraud and privacy, but also if you've got operators who are involved in the biometric and document resolution, there's a requirement in the TDIF that those staff need to receive training on facial comparison and limited sort of document examination. And that is part of the TDIF requirements, and we can provide the training to meet that requirement for the TDIF. So wrapping up, so we can obviously provide this workshop, also providing custom workshops depending on your needs, evolving into different types of training. And really importantly, with the different type of audience and the response we've had here, we also provide sort of a complimentary initial appraisal on the requirements for certification. So if you have a product and you're not sort of sure on the direction of what it might need in terms of certification requirements, or you want to be a part of you want to be a part of MOSIP, you want to be a part of TDIF, we can help guide you towards what you need to do to get there, and provide the relevant testing to meet a number of the requirements of those different frameworks and programs. So that really sums up that last part. So I'll hand back to Ted and also to the floor to look at different questions. I think a couple have come through the chat, and invite those questions now for anyone that has them. Thank you.
Thanks, Stewart, and thanks to Somya and Sanjith as well. I hope you found this to be interesting and informative. We have 5 minutes now for questions. I know we've got some questions in the chat. So maybe I'll read out the questions, and Somya and Stewart, you might like to have a quick go at answering. The first one was from Raymond, which relates to if the ISO standards are older, is there a better accreditation that we should look out for, or does BixeLab do additional tests? And also, are there accreditations for document authentication?
I'll cover that one. So while some of the ISO standards, 19795 and 3107 have been around a while, but they're also they're very mature standards as well, and they really drive a lot of the other frameworks and things that we've spoken about today, like 19795 and 3107 really drive the FIDO biometric requirements. What FIDO really then does is just go one step further and actually provide here's an actual performance target that you need to meet. Whereas those standards are really not about meeting a performance target, but about how you report on that and how you actually do the testing. We recognize and appreciate that those standards are not applicable for all types of scenarios. And that's really where in the previous slides we spoke about a level R type evaluation. And we've done a few of those for situations where a 3107 evaluation is not necessarily appropriate, and you can get better results out of a red teaming type exercise. So we do have additional tests. It just depends on the type of scenario. Whereas comparatively, sort of a pad level 1 or a pad level 2, we do that type of testing. We provide you what you need, and our clients will often then go take that because they're trying to be a part of an identity framework or something like that. So it depends whether you're just looking for a simple certification to meet a requirement, or you really are deeply interested in understanding the vulnerability and performance. For that question on document authentication, I'm not aware of any other accreditations around the document part. The document part is really quite new, and when you talk about the concept of document examination, that's really a forensic and a very manual type of process. But then in this type of solution, you're talking about doing that automatically using technology. And also asking your operators that might be within your call center or whatever to try and do that document authentication based upon a photograph. That's quite a difficult task, as you can expect. There's a strong, if you look up this type of concept of document examination, is, as I said, it's a very forensic and manual process, and applying it in this digital identity or in an eIDB type product is very different. And I would look forward to any sort of standards that come into play around that. But at the moment, it's a very manual process, and there's not really any accreditations.
Having said that, BixeLab has accredited solutions that have this as part of the solution, so we can do some of that testing, but we certainly don't currently. There are no formal kind of accreditation standards per se. There are accreditation standards that we use. I think, Stewart, you answered some of Sabine's questions. Aziz was asking about the gap type in terms of artifacts, and you're correct in terms of the fact that the artifacts are somewhat more constrained in terms of what's in level 1, 2, and potentially 3. And certainly when we do a level R evaluation, that is what we focus on, those more complex types of attacks.
Yeah, it's a spread across sort of a level 1 and 2 and 3. But noting that a level R is the idea with that evaluation is it's tuned heavily towards the use case. So we look at different types of attacks that are more likely to be successful based on a use case. So you can imagine something like a mobile app. that opens up different types of attacks to, say, an access control system mounted on a door. So yeah, the idea being you tune those attacks that you and tests towards the use case and the product that you're testing.
Yeah. Thanks. Two other questions were Don Green asks about consultancy and education services, and certainly we do that for clients in terms of helping to upskill them in terms of making sure that they've got the right services, and in some cases we certainly do evaluations for end users, so for banks, etc. Yeah, if there are people that are interested in those services, that's something that we've got quite a lot of history of providing. Then the last comment is around the document authentication. Any document authentication process is difficult because you have this issue to do with making sure that you've got an authentic document. In Australia, one way that is handled is through what's called the document verification service. So the government maintains a service that allows you to check whether the biographic details are correct on that particular document. However, if you are using a document and you're trying to match off a photograph which is just printed on that document, it's extraordinarily difficult to be able to pick up if that document has been tampered with, where people are able to produce reasonably good facsimiles. There is some good technology, but yeah, it's pretty tricky.
Yeah, and I think just to wrap up that question too, the one thing I always remind people when it comes to that type of product where you're taking a photograph of your document, where, you know, when people are under 18 and trying to get into a pub and when they're not old enough, they're buying a fake driver's license internet, they're getting a physical artifact that resembles a driver's license. It's a physical thing that kind of looks like a driver's license when you turn it around. But when you turn that whole identity verification process into a photograph of that document, the objective of an attacker is no longer to create a convincing fake document. The objective is to create a convincing photograph of a document, which is very different. So while it might be difficult to make a driver's license on the right plastic with all the right holograms, it's very easy to make a two-dimensional bit of paper, which when photographed just looks like a real document anyway. So that's an important distinction. And when people are talking about eIDV and document examination, I'd encourage you to distinguish between a physical presentation of a document versus the photograph, because they're totally different and barely even comparable in most cases.
Yeah, and just to follow up the last point that was mentioned there, the issue obviously is that in many cases where the documents are being captured, they're being captured by an optical camera that doesn't have access to UV or IR or other sensing technologies. But it will be interesting to see where that technology goes in the future. I'd like to thank everybody who was able to attend and stay to the end of this presentation. Thank you so much for being part of this workshop. I'd really encourage you to reach out to us, obviously. We're more than happy to do a one-on-one chat with anybody if you have other follow-up questions. And we will distribute a copy of the video here so that if you've got other colleagues that you would like to share this with, then feel free. For those of you that would like to stay on for a bit longer or have a bit more time, welcome staying for a few more minutes to answer any other questions, either in the chat or via a video conference. But thank you all.
There is one question that we have around if it's available to undertake our PAD certification process. The answer is most definitely. And then around the benefit of our lab against other potential offerings. If I mention that just briefly, and Ted might have some other words to say, BixeLab is a sister company of Biometrics, which has been providing services around biometrics and identity for over 20 years. We're a biometrics company through and through, and we've been involved with lots of very large scale projects around the world from the early days. And our specialization is in biometrics and biometrics testing. Other laboratories that might provide similar type of service that are also accredited are testing laboratories. And while they may have experience in the accreditations, that they're not necessarily specializing in biometrics and don't have that deep knowledge of large scale biometric deployments that we do, really just the technology. So, but whereas we're across the large scale systems and deployments and use cases, as well as the technology itself.
Yeah, it's not a turnkey for us. We really deeply understand and appreciate the issues in terms of deployment, and so we feel that we're able to go the extra mile compared to other alternatives.
As well as diving into other types of areas like the level R evaluations is a unique to BixeLab offering, as well as those different types of questions that you might have that extend outside simple presentation attack detection, like bias, where it becomes a bit more complex.
Yeah. One question we also had was how long an evaluation takes. So in general, evaluations take between 3 and 4 weeks. Depends a lot on the type of evaluation, but that's a rough guide. Somya, did you want to mention anything in relation to? There was just had a question about the length of time to do an evaluation.
Thanks, Ted. So normally it would take us somewhere between 4 to 5 weeks, given there's no operational delays. When I say operational delays, when we talk evaluations, there's a lot of setup time involved. When we do technology evaluations, there's API setups, etc. When we do bad evaluations, there's artifact creation time, etc. Designing the test cases, doing the pre-testing. So inclusive of all of that, I think it's closer to 5 weeks mark. But that is given there's no technical delays. That makes sense.
Yeah. Thanks, Somya. Okay, have we got any last questions? Happy to take. We've got time for probably just one last question. If anybody's got anything I'd like to ask, feel free to unmute yourself and ask directly if you like. All right, sounds like we have a wrap. So thanks everybody for coming, and thank you to Sanjith, external presenters, and also to Somya and Stewart for coming on board. Thanks, Sanjith. Appreciate your time and presentation. It was really good.
Thank you very much for the opportunity. Nice meeting everyone.